Hi viewers, welcome again to the continuation of the differential equation. We stopped at formation of differential equation and we've treated how we can know if a differential equation is first order or the order of any given differential equation, and also how we can know the degree of any differential equation. But how do we solve this differential equation? Don't forget, we need to consider the degree of any given differential equation. In the video we want to make today, we are going to consider the first degree. Now, in solving differential equation, we have various methods, but we are going to consider in our video today the separating the direct integration method. Direct integration method. Direct integration method. Why are we using this method? Consider any given differential equation. Let's say you have the y, the x, and this can also be written as this. This is first degree and first order. And is given as function of x. You discover that the differential part of it is separated from the given function. Here we can integrate direct, or if you have it like this, like the square y, the x square equal to 4x plus 3. We can integrate this direct as well. This is second order but first degree. When you are given any function in which the differential part of it is separated from the function of the independent variable, then we can just integrate using direct integration method. Other methods are going to consider if the differential part of the differential equation and the function of the independent variable are merged or not separated completely. We want to consider some questions here. So let's take this question, for example, integrate or solve the following differential equations. The y, the x equal to 4x plus 3. And the second one, the square y, the x square equal to 5x squared plus 3x plus 1. So we want to take these two as example for direct integration method. Now, I explained two things when we started this differential equation. We can have general solution and we can also have particular solution. We are considering general solution if you just integrate directly and insert the integration constant terms. But if you are considering what particular solution that differential equation belongs to, you have to find the value of the constant and then you'll be given the points. So in this differentiation, we want to consider only the general solution, since the points of the coordinates are not given, we just integrate directly. Let's solve these questions. Like number 1, we have the y, the x equal to 4x plus 3. So to find the general solution of this, we have to integrate both sides. You integrate this, that is the y, the x equal to, you integrate this as well, 4x plus 3. And when you cross multiply, you are going to have integral of the y equal to integral 4x plus 3 with respect to the x. I've taken this to this side. And if you integrate the y, you are going to have y, which is the dependent variable. Now, the independent variable here is x. Don't forget, we are adding 1 when you are integrating. When you add 1 to this, you are going to have a 4x, 1 plus 1, that's 2. You are also dividing by that power, and this will also be over 2. Plus, this is a constant term. When you integrate any constant term, that function of the independent variable must be repeated. X, 3x, and you have plus c. This plus c here is the integration, a constant term which you must apply to any differential equation. So we can cancel this and this. We can now have our value to be 2x squared plus 3x plus c. This is the general solution of this differential equation. Let's consider the second part, which is the square y, the x squared equal to 5x the square y, the x squared is given as 5x squared plus 3x plus 1. So how do we integrate this? We are also integrating using this direct method, because the function of the independent variable and the differential part of it are separated completely. We can write this as, we can also write this as, d of the y, the x, equal to 5x squared plus 3x plus 1 with respect to the x. That is, if I have this like this, the x, this will be here. By the time I cross multiply, I take this to this side, so you agree with me that this will be written as d of the y, the x, equal to 5x squared plus 3x plus 1, then the x. So now I have to integrate. When you integrate this, if you integrate both sides, you have d of the y, the x, equal to integral 5x squared plus 3x plus 1. Then with respect to what? The x. And this will cancel. When you integrate this, you have the y, the x equal to, when you integrate this, you have 5x is to the power of 3. Don't forget, we are adding 1 to the power over 3. We are dividing by the power as well. Then plus 3x, add 1. This is 1. 1 plus 1 will give you 2. All over 2. This is the constant term. Anytime you integrate constant term, the function will repeat itself there, and you are going to have 1x, which is the same thing as x. So we need to put a differential integration constant, which is plus c. So we are putting, let's say, c1, because we still have another differential part we want to consider. So if this is the first constant, then we can call this one c1, and when we integrate again, we are going to have a c2. So let's say what we do here, we integrate both sides again. Let's integrate both sides again. We have the y, the x equal to 5x cubed over 3, then plus 3x squared over 2, then plus x plus c1. We have to integrate both sides again. And when you do that, you are going to have integral the y, the x equal to integral 5 over 3 x raised to the power of 3 plus 3 over 2 x squared plus x plus c1. So let's cross multiply. We have integral the y equal to integral 5 over 3 x to the power of 3 plus 3 over 2 x squared plus x plus c1 with respect to the x. So when you integrate the y, we're going to have y, which is the dependent variable, equal to, this is 5 over 3x. We are adding 1 to this power. This one will be 4 plus 3 over 2 x. We are adding 1 to this power, which is what? Don't forget, we are also dividing this by 4. You divide the power by this. So this will be 3 divided by 3x squared. Then plus, add 1 to this, it will be 2. X is to the power of 2 over 2. Plus, add 1 to, we are differentiating this, integrating this as well. So it will be c1x. So we have to put another integration like constant. This one will be c2. So this is the solution. We are only considering the general solution. Don't forget, if it is particular solution, the coordinates of x and y will be given. Then when we insert it, this will lead us to simultaneous equation. But this one is just a linear equation, which we can find the value of the constant term here, c. And this is how you can integrate differential equation using direct method. In our next class, we want to consider other methods of solving differential equations. Thank you so much.